Hi, today we're going to talk about composite functions. So composite as a word, straight out of the English dictionary, means made of different parts. So let's take a non-math example of something that's made of different parts. So we have this guy here, this little stick figure, and he sees this tree, and he decides he's going to make some money. So he takes this tree and he chops it down, and then let me put that over here. Okay, so he's chopped this tree down. Oh no, the tree is dead. There we go. He's going to take this tree and he sells it to a lumber company. And the lumber company is going to take it and they're selling it to a paper mill. So this tree goes inside of this big giant grinder. So this is a paper grinder, a wood chopper or a wood grinder of some sort. Anyway, this goes in as your input. And all this stuff happens, it gets all kind of shredded and ground up, and then over here you have this outflow, and what comes out of this outflow is, let's see, you have all of this like sawdust and wood chips, and this is just, it's shredded tree is what that is. So that's your output. Okay, well that isn't very useful just by itself. So what happens is the paper company takes all of this stuff and it puts it into this other machine, and this turns into to the input of this other machine, and they're going to add water and some chemicals and stuff, and all this stuff happens. They heat it up and break it down and do all kind of funky stuff to it, and then this big mushy like gelatinous muck comes out, and it's this, they call it pulp. So this is like a wood soup kind of. So this is pulp. And then this pulp comes out and they stick that in another machine. And this other machine takes this pulp and it heats it and does all kind of weird stuff to it. They bleach it to make it funny colors. And then they stick it on a conveyor belt. They flatten it out. And eventually it turns out to be a piece of paper. So things are usually made like this in process, in like a step-by-step process. You don't just take a tree and then you chop it down and all of a sudden it's paper. It goes through stages. So first you have an input is your tree. It goes through one process. Let's call this h of x, if your tree is an x. Your x goes in, it goes into this function h of x, it comes out, and you get something else. Well, the output from your h of x function goes into this other function, we could call this g of x. So the outflow from the h of x was our chipped up wood, and that turns into your input for your g of x, and then the output is our pulp, and so that goes into this new function, let's call that f of x. So your pulp is your new input, and then from there you get an answer, which is your paper. This is basically what a composite function is. You take the output from one and you stick it in the next function. And then you take the output from that function, you stick it in another function, and then you stick it in another function until you run out of functions. The way you would write that is you would say in this last example we had f of g of h of x. So your x was your tree. Out came the wood chips. And then from there it turned into pulp. And all of that ended up as paper. Paper. So we're doing a function, but we're doing it in stages. So if we were looking at this as math, which since this is a math class, that kind of makes sense. If your f of x, let's say you have f of x equals 2x plus 1. And let's say you have another function g of x, and your g of x is 3x minus 2. And then let's say we have an h of x, and your h of x, let's call that just an x plus 4. Okay, if we're doing f of g of h of x, sounds kind of weird. Okay, so we have f of g, let me put this in yellow, g of h of x. Only let's do a number. Let's say we want f of g of h of 2. I'm going to put 2 as just a different color because that's just our plain ordinary input. Okay, so we have Close parentheses there, close parentheses there. We have parentheses all over the place. This is enough parentheses to make your English teacher scratch your head. Okay, what you're going to do is you're going to start from the inside, right? We're going to do h of 2 first. So if we do h of 2, so h of 2 is going to be, so our h is x plus 4, so we have 2 plus 4, because your 2 is just your x. We plug that in where the x went. So 2 plus 4 is 6, right? Da-da-da. That's our output. So this 6 is what gets plugged into our g. So our g function now, we're looking at our next level out. So we have g of something. Well, that something is the output from the one inside. So this 6 gets plugged in instead of an x. So now, if we do that, so our g of x function was 3x minus 2, so we're going to have 3 times our x, which is 6, minus 2. Well, 3 times 6 is 18, and then 18 minus 2 is 16. So this is 18 minus 2, that gives us 16. So our 16 is now the x value for our f. So we're doing these in layers. Okay, so we're going to do f of, I'm going to put this in yellow to show us that's where we got it. We're not just picking random numbers. Okay, so our f function was 2x plus 1. So we're going to have 2 times, our x in this case is a 16, plus 1. Okay, 2 times 16 is 32, plus 1 equals 33. So that's the whole overall answer of our problem. So in this case we would say f of g of h of 2 is just 33. And we're going to talk about these more in class. You could plug it in as your x, or you could just plug functions inside of functions, which gets really kind of crazy. So that one we are going to do in class. But just know that when we're talking about composites, we're taking the output of one function and we're using it as the input for our next level function. And then we use the output of that function as our input for our new one. So like we use the output of our h to go into our g, we use the output of our g to go into our f, and then the output from our f is our answer. So those are composite functions.